In this video, I solved the proof of binomial distribution when it approaches to Poisson distribution. If small n approaches to infinity and p, the probability of success approaches to 0. So the probability mass function for binomial distribution is given by p of x, ncx, p raised power x and q raised power n minus x, where the range of random variable x is from 0 to so on n. So using the combination formula n factorial x factorial n minus x factorial p power x and q, we write q equal to 1 minus p. P plus q is equal to 1 and q is equal to 1 minus p whole power n minus x. So if p is very small and n is large, we use lambda is equal to np and p is equal to lambda over n. So this relationship is used, p is equal to lambda over n. So p of x is equal to n into n minus 1, n minus 2, so on n minus x minus 1, n minus x factorial over x factorial n minus x factorial. Lambda over n raised power 4 raised power x and 1 minus lambda over n power n minus x. Put the values of p in this equation. So taking n common, when we take n common, we left with 1 minus 1 over n, because here we have 1, we multiply, for suppose that with n and divide also n. When you take small n common, n take common and we left with 1 over n. So 1 minus 1 over n, here 1 minus 2 over n, so on n 1 minus x minus 1 over n, lambda over n raised power x and 1 minus lambda n raised power n minus x. So n power x and here lambda x n x into 1 minus lambda over n whole raised power n minus x. Cut this nx with this nx and applying limit n approaches to infinity to both sides. N approaches to infinity to p of x and also applying limit n approaches to infinity. So where n applies 0 and we left with n approaches to infinity 1 minus lambda over n whole power n lambda x 1 minus 0 power minus x over x factorial. So here lambda x and all other is 1, limit n approaches to infinity 1 minus lambda over n, this we solve this number and we multiply this with lambda over lambda. So 1 over lambda multiply with, we write is n over lambda and lambda power is there, we multiply and divide lambda. So this relationship when applying limit is equal to e raised power minus 1 whole power lambda. So we write it as lambda power x e power minus lambda over x factorial. So we proved that the relationship when small n approaches infinity and p approaches to 0, then binomial distribution approaches to Poisson distribution. If you want to see videos about discrete uniform distribution, Bernoulli distribution and binomial distribution, you can find all proof of this distribution on my channel Statisticians Club. And you can also find in future the proof of discrete and all continuous distributions. Keep watching my channel Statisticians Club and also subscribe the channel Statisticians Club. Thanks for watching.